I hate my job. I entered corporate America full time about 2 years ago in cybersecurity. It sucks. I spend 40 hours a week providing no tangible benefit to anyone except for maybe keeping some very wealthy people from having to pay fines after an audit. What I always wanted to do was make video games. Unfortunately, my secondary education was pretty poor, and the little bit about programming I did learn has fallen much out of practice. Now, I've started learning game dev a few times, but I keep running into the same issues. I either don't have enough ideas to scope out a project of my own, so I get to the end of some tutorial and have no idea where to go next, or I do have an idea for a simple mechanic, create it, and don't know where to go from there. What I don't know about myself is if I keep failing because of my lack of ability or because of my lack of creativity. Now, I can deal with not being creative enough to make a game, but I can't accept for myself that I am incapable of acquiring the skills necessary. So, with that background and the context that I really am sick of corporate life, I decided screw it, I'll just copy something that already exists. Now, you've already seen the title of this video, so I'll spare you the suspense. I decided to remake the 2001 Game Boy Zelda game, Oracle of Ages. I wanted to keep the scope pretty limited, so my mind immediately drifted to Game Boy, but a lot of Game Boys are a little too simple for what I was trying to achieve. Take Mario Land, for example. It has like 5 mechanics total, and then after that, it's just building the levels. On the other hand, just off the top of my head, Zelda has a basic movement system, combat, an inventory system, a dialogue system, events, progression flags, as well as a lot of unique interactions between the player, the world, and the objects in it. Furthermore, I like playing games on my PC and my Android handheld. Now, there's been a trend recently of porting classic games to PC with various quality of life improvements. Typically, this is done by decompiling the original game's assembly back to C so that it can be ported to modern hardware with 100% authenticity. Now, this is a much more impressive accomplishment than what I'm trying to do, and one that I'm not equipped to do. I will instead be recreating the game as accurately as I can in a modern game engine and compiling that executable for modern operating systems. Which leads us into the discussion of game engines. Now, I'll spare you the video essay about what a game engine is. I mean, you clicked a game dev video, you've probably heard Unreal Engine explained to you 8 times this month. Now, the first option was to create my own game engine with my own renderer, an input handler, an audio handler, and all the stuff that makes a game a game. Now, it has several advantages. I would be in total control of the exact implementation of every feature. I would only have to implement features that were actually used in the game and nothing that wasn't. I can make the game ultra efficient for low powered or battery operated devices. However, please consider that I don't want to do any of that. Making your own game engine is a lot of extra work on the front end before you can even create anything close to resembling gameplay. On top of that, I want to get familiarity with more industry standard tools. Remember, this project is about trying to learn skills applicable to actual jobs. This project in and of itself is not the job. The devlog is not the job. So really, there was only one option that provided really great tools to make a simple 2D game. That's right, we are using Unity. First, let me address the Godot-shaped elephant in the room. Godot is kind of the trendy new kid on the block. From my understanding, it's probably the most user-friendly engine for a burgeoning game dev. It's probably the right tool for this job. However, going back to the main reason for this exercise, it's to learn skills, and as a first project, I want to learn a broad set of skills. I think Unity, despite its controversies, is a pretty vanilla and standard tool to learn. I also think that learning Unity as a baseline will help to transition to other engines in the future, like Godot or even Unreal. I also am probably making it sound like I spent a lot more time thinking about this than I actually did. So, we have our project, we have our engine, and we have our scope. We're ready to get started, right? Well, yes, but actually not quite. See, the nice thing about copying someone else's homework is that we have finalized assets right off the bat. I'm trying to make a faithful recreation of Oracle of Ages, and that includes the art. Now, I would love to learn art, but I actually know nothing about art, and I don't want the whole project to get demotivated and derailed because I'm struggling to create assets that I'm happy with. Anyway, since we have finalized assets, I would like to start working with those instead of doing the whole white box as a stand-in for the player thing. I don't need to get all of the assets ready right now, but I at least want to get started on making some maps, basic player movement, animations, maybe an enemy or two, that kind of stuff. Common sense says I should have started with the player, but I have programmed basic player movement before, and I figured it would do well for my motivation if I saw something that resembled a final product right away. I also figured it would be best to start on the map early since it may end up being the longest and most tedious part of this whole project. I also knew that I would probably have to get clever with how I implement it. I could just take the whole map, import it as a background layer, and then manually add collision where necessary, but that would be very time consuming, messy, prone to human error, and redundant. What I really need is a tile map. Thankfully, this is something I could get pretty quickly with some Python code. Fortunately, every tile in the game is exactly 16 by 16 pixels. The main problem is that whoever uploaded these maps, who uploaded these maps? I meant to write that in the script, but I did want to give them credit, so I'm gonna find this right now. Okay, here it is. So shout out to Mr. Mike for the map, the link sprites, the item sprites, and the enemy sprites, and then Darth RPG for the sprite effects. Anyway, the main problem is that when this map was uploaded to the Spiders resource, Mr. Mike added a green border at where the screen transitions would be. This is incredibly helpful for when it's time to actually lay out the map, but adds some complication when trying to programmatically split the map into individual tiles. Fortunately, again, each screen is exactly the same size at 10 by 8 tiles. If you're wondering why the screens are only 10 by 8 instead of a 10 by 10 square that fits the Game Boy's resolution, the top part of the screen is reserved for the HUD. This consistent sizing of screens means I could split the image into equally sized screens with 1 pixel border on the left and on the top. Here's the code that does that. From there, I just need to crop each of those images to remove the border, then I take the remaining images and chop them into 16 by 16 tiles. Now I have every individual tile in the map. Now, technically, since I programmed it in such a way that each 16 by 16 image is in order, I could throw these into Unity as is and have the full map created in a couple of seconds. However, this would be extremely redundant because there are actually only a handful of unique tiles that are used throughout the map. Also, when it comes to things like programming collision later, I don't want to go through and set the collision tile by tile. It makes much more sense to just have a handful of unique tiles and define each one as floor or wall. So, to get a set of all unique tiles, I took a hash of the color value of each image and stored that alongside the file name in a Python dictionary. I can then iterate through the dictionary by setting the comparison value to the first item, and then checking the next item. If the value of what I'm checking is the same as the value of the reference, I mark the tile I'm checking for deletion. If the value I am checking is different than the reference, I know that I have reached a new unique tile, so I update the reference to the new spot and keep checking. When the loop is finished, I delete everything that I marked for deletion, and I'm left with only the unique set of tiles for that map. Now all I have to do is stitch the tiles together, and we are finally able to open Unity. The first thing I did with my freshly created scene was add a grid component to hold the map. I made a child object called background and added tile map renderer, tile map collider, rigid body, and composite collider components to it. This was in real life a while ago, so I don't remember exactly if all of those components were necessary. I'm squinting right now at the composite collider as I'm writing the script and wondering if that really needs to be there. Anyway, I can now import my tile map. First thing I noticed when I imported it was that it was really blurry. Some Googling later, I learned that Unity, for some reason, imports sprites with a bilinear filter already applied to them. After switching it to point or no filter, everything looked fine. I also set the sprite mode to multiple and set the pixels per unit to 16 so that it automatically identified the individual tiles. I also don't know where else to mention this, but I noticed for some reason some of my sprites would import with the colors slightly off. To fix this, I had to change the format from automatic to RGBA 32-bit. I don't know exactly why, but I'm guessing it has something to do with the alpha channel. I really don't know, though. I tried dragging my newly imported tiles onto the scene editor, but no, there's one more step before we can paint on our canvas. I had to create something called the tile palette. It took me a second to get used to the controls, but it was pretty easy once I got the hang of it. I then spent a few hours organizing the tiles. I primarily sorted by color and tiles that blended into each other, like walls and floors. Now, before I actually started placing the map down, the first thing I did was lay out markers for myself every 10 tiles horizontally and 8 tiles vertically. This helped me divide the work of placing the tiles into the original screens. This makes it very easy to fix any misalignment issues later. After setting my markers, I decided to work on the map from bottom to top. The main reason for this is because there's a lot of water at the bottom, so I figured I could get it done pretty quickly. After finishing the island at the southeastern corner of the map, I got bored placing tiles for the day, so I decided to finally start working on the player. Link actually has a pretty big sprite sheet, but I figured I'd only focus on walking right now. I cropped down the sprite sheet to just 4 sprites for walking, removed the background, and imported them into my project. I then created a player object in my scene, added a sprite renderer to it, as well as a rigid body. A rigid body is just Unity's way of defining an object that can be affected by physics. Since it's the top-down game, I set the gravity to 0 and lock the rotation since there's no sprite rotation in the original game. Anyway. Oh no! I lost all of my script about the input controller. I am just now realizing I must have erased or written over the bit where I explained Unity's input system, so I'm going to do that off script, and if I hate it, I'll go back and record this, and if I don't hate it, just bear with me, I'm going to ramble about it for a second. So, after looking into it, Unity has kind of 2 input systems, a more legacy one and a more modern one. I stuck with the more modern one because I figured the old one would be deprecated eventually. So the new system is actually pretty cool. So what you do is create what's called an input action, and the input action is kind of 3 parts. There's the action map, so you can have a different set of actions for like your regular gameplay, your menus, like if you got in a vehicle or something. And then with each of those, you set your bindings. You can set bindings for keyboards or gamepads or whatever input devices. And then for each of those inputs or bindings, you actually set the parameters of the input. So like if it's like a trigger, or in the case of movement, you'd set it as a vector too, so you have the X and Y component. Also, the name of the binding is the name of the method that will get called whenever you press the key bind. So as long as the script exists on the same object as the input action, it'll automatically find wherever that method is and execute it. And I don't think I hated that, so y'all can deal with that. Anyway, now that I have my input action set up, I could go to my player controller script and make Link move. This is really basic, and you'll see the exact same code in every beginner Unity tutorial ever. First, I define a float so I can set the speed, and a vector2 to store the input. When the player's initialized, I get a reference to the rigid body component. Then I create a method called move. I pass my input action into it and set my vector2 to whatever the value of the input is. Finally, in fixed update, I just set the position of the character to be the current position plus the value of the input times the speed times time dot fixed delta time. I don't remember what exactly that does. I think it has something to do with synchronization for different frame rates or something. I don't know. It was in the tutorial. So now I have a player that can move. Yippee skippy. Let's get him animated. Yippee skippy? Did I really write yippee skippy? You know what? I'm leaving yippee skippy. I'll start with the walking horizontally animation. First, I need to add an animator to the player, then create an animation clip. If you're following along at home, make sure you have the player object selected, because you can't specify what object you want to animate in the animator window for some reason, and it took me way too long to realize that. Now I add the clip to the animator, and then all the sprites of this specific animation to the animation clip, which in this case is just 2. I place the first sprite as frame 1 of the animation, and the second sprite about halfway through where I think the animation should change. And there's probably a way to extend the length of the animation without adding another sprite, but I didn't want to figure out how to do that. So I just duplicate the second sprite at where I think the animation should loop, so it doesn't quickly switch back to the first frame. Alright, now for walking down. There's only 1 frame to this animation that gets flipped back and forth. This was pretty common practice back in the day to save resources, but you'll still see it used today to save time. Now I could just open the sprite in GIMP, flip it, and animate it in the same way as before, but I don't want to do that, and I want to get some familiarity with how I can interface between my animations and my scripts. Here's where I learned about a pretty important concept in Unity: coroutines and IEnumerators. Coroutines, for the programmers out there, seem to be Unity's implementation of multi-threading. I don't know if it actually runs the code on a different CPU thread. My guess is that it just shares CPU time as needed to maximize single-thread performance, but that's neither here nor there, and I'm just guessing. For the non-programmers out there, code is typically executed in line from top to bottom, like you're reading a book or following a recipe. If you have something that needs to loop or repeat, you have to complete every repetition before moving on to anything else. For example, if I wrote a program, you know what? Legos are a good example of this. So let's say I can write a program that can build a Lego. If I were to do that, the program would have to go piece by piece from step 1 to step whatever, just like you or I would. But in real life, I could have a friend, for example, build a different part of it while I'm working on the main part. Multi-threading is like doing that with code. If I wanted to build this at the exact same time as I was building this, I'd have to write special bits of code that allow the machine to do that. Bringing it back to the game, I need to write code that animates the player at the exact same time as the rest of the game operates. I can't have the game stopping to animate the player. And that is exactly what a coroutine is. It is, and I'm simplifying here, a method we can call without halting the rest of the code. It uses the data type of IEnumerator. I don't actually know what that means. The good news is I don't need to know how it works or why it's named the way it is. I just need to know that it does work. So anyway, within my IEnumerator, I write code that says for as long as the player is holding vertically, flip the sprite direction. Wait for a bit, then flip back. Otherwise, we stop the coroutine entirely. Now, whenever the player presses up or down, I start the coroutine and pass in the code that actually flips the sprite. And it works. We actually do something similar for walking to the right, since it's a mirror of the walking left animation, but I actually don't need a separate coroutine for that. I just check if we are walking to the right and flip the character if we are, since the animation itself has distinct sprites. So after all that, we have walking animations in all four directions, and I'm feeling pretty good. I need to actually play these during gameplay though, which is where I start working a little more closely with the animator. The animator itself is just a canvas where you essentially draw state machines for animations. Every animator first needs an entry state. That's easy. I just made idle animations in each direction and set the default to be the idle where Link is facing the camera. Now I need a way to find which direction Link is moving. For this, I can add two float parameters to the animator called horizontal and vertical. I can set these in code by getting a reference to the player's animator, then calling animator.setFloat on whatever I name my parameters, and setting those parameters to the value of the component of the vector2 that represents the player's movement. Easy enough. Are you starting to see why it is so tedious to learn a game engine? Because every little piece has to have a reference to every little piece, and it's hard to keep track of what is what when you are brand new to it. Anyway, now I can drag my three walking animations onto the animator and make transitions from the idle state based on the value of my horizontal and vertical parameters. This technically would mean that I have to make a transition from every animation to every other animation, because the player can go from walking in any direction to any other direction or idle. The good news for me is that I learned about blend trees. Blend trees are awesome. They pretty much allow you to combine multiple animations together based on parameters like I mentioned before. They seem to have a lot of options, but my needs are pretty simple, so I didn't dive too deep into it. I just set the blend tree coordinate plane to my movement parameters and then add animations based on which ones are set. Now all I need to do is set a single transition from idle to walking and walking to idle, and we're done. I don't really have a better place in the script to point this out, so I'm just going to say it here, but you may notice that things like speed or the timing of animations are way off from the original game. All of this stuff can be tweaked pretty easily without breaking anything later, and it is a pace killer to go in and tweak everything to perfection right now. I think for this project, I'm going to microanalyze every little aspect of the original game when I reach the end as a cleanup effort. Now, I'm going to hate myself later for this, but for now, it lets me move between features and learn different things faster. I wanted a little more experience with the animator before moving on to the next feature. So I decided to add link sword slash animations as well. Now, I did this pretty much the exact same way as before, the only difference being instead of using movement parameters, I added a trigger parameter called attack that I can set in code when I press a certain button. That way I can just set the condition of the animation transition to be if attack equals true. Now, I would later come to regret how this is set up, but we'll get there when we get there. At this point, I was getting kind of sick of the animator and just wanted to turn my brain off for a bit and watch YouTube, so I went back to painting the world. I pretty much finished the ocean to the south and the forest section to the east of the castle. And I should note that at this point, the map didn't have any collision, so I took some time to figure out how to set collision on tiles. Now I can walk on the grass, but not on the trees. When I set this up originally, I feel like I had a way to set the tiles that had collision in a bulk process, but I cannot figure out how I did that. I've since had to go change some tiles because I messed up the original settings, and I can't remember how to see what does or does not have collision, so I have to check them one by one, and that kind of sucks, but it's whatever. I'll also point out that I am aware of rule tiles. Rule tiles are special tiles in Unity that contain a bunch of tiles and rules on how to place them based on the tiles that are around them. For example, when creating things like paths. I've played around with these in the past, but I think they make more sense in a game where you are creating original content because they can be a time saver as you're modifying your world. Now, in my case, I could, for example, make a world tile for the grass, but because every individual blade of grass and flower has a specific place, I'd have to do a lot of manual placement anyway, so I wouldn't be saving that much time. On top of that, I'm generally taking a screen by screen approach rather than filling entire sections of a certain ground type, and the stop and start nature of this doesn't really lend itself to roll tiles being helpful. Anyway, I now realize I had a pretty big and open forest area and a sword slash animation, so I figured I could add an enemy. I started with the Octorok because they're pretty common, weak, and simple. Now, at this point in my life, I have forgotten a lot of programming design principles, but I know there are going to be a lot of different enemy types in this game, so I made a base enemy class with a couple parameters and methods that I figure all enemies will have. Things like health, contact damage, movement, etc. Then I created a Nocturok class that inherited from the enemy class. I added some quick animations the same way I did before, with a few unique sprites and rotating the character based on direction. Now, I really ended up liking how I handled enemy movement. It isn't super original, most of this code isn't, but it is clever. First thing I do is make an enumerator with the possible actions. I was originally going to explain what an enumerator is here, but I'm starting to bore myself, so we're going to skip past it. So I created an enum called possible actions and gave it the values of move, idle, and shoot. Then I made a method that chooses an action. I also created a weighted choice class. All that does is store the value of an enum and the weight, which is an integer that represents how likely the choice is to be made. I then create a list of weighted choices and define the likelihood of each choice. Now here's the clever part. To make a choice based on the weights, I first sum up the weights of all possible actions. After that, I check each action one at a time. If the number rolled is within the weight value, it is chosen. If not, we add the weight of the action we're currently checking to our counter and then check the next action. That might not make any sense when I explain it out loud, but it means that I can very quickly edit how likely certain actions are to be taken, and the weights don't actually have to add up to 100%. Now all I need to do is set up another code routine so that the enemy occasionally makes a new choice, and set up a switch that references my enumerator from before. Now for now, I've actually only written functions to handle idling and movement, not shooting, but it's set up to be easy to add whenever I decide to get around to it. Now I want to be able to actually kill the enemy, and this is where I realized I made a horrible mistake. See, earlier when I made my sword slash animations, I just used the complete sprite from the sprite's resource. However, things get messy if I do it this way because my player already has a collider. I can't add a second collider directly to it. I can create a child object that has a collider and then move it along with the animation, but that's pretty arbitrary and not very intuitive. This slash animation also gets reused for other items in the game, like the other swords, the staff, and the rod. Now, I had this thought in the back of my mind earlier and figured I'd address those concerns when I got to them, but unfortunately for me, that time is now. Ultimately, the solution wasn't too complicated, but it took my slow brain a while to get there. The first thing was to remove the sword from the slash animation. It took a little longer than I would have liked because GIMP is like that. Anyway, I then create a child object of the player called weapon, and a child of that called sword. I add a separate sprite renderer and hitbox to the sword that starts disabled. Now I can enable both the sword sprite and the hitbox during the animation, and disable them after the animation. I ran into this weird bug where the sword was trying to move back to a different point after the animation was finished, but while the renderer was still active. I solved this by making sure the renderer was set to false during the idle animation, and that for some reason worked. Actually, I found myself struggling with positioning a lot during this project. If you're getting into Unity development, be very careful about what you're moving. Every object inherits its position from its parent, which makes perfect sense, but it's really easy to accidentally move a child rather than the parent. For example, if I click and move Link around in the scene editor, that only moves the sprite, which means everything is entirely off base. Just make sure you're always moving the parent rather than any children, unless you're specifically trying to move a child relative to the parent. Anyway, now I can kill enemies. I'll gloss over some of the specifics, but I added health to both the player and enemy and contact damage. It was very easy and not worth talking about at all. Since I could take damage now, I wanted to add some special sauce. I was playing through the original game and noticed that when Link or enemies take damage, they always flash the same colors. The darkest color on the sprite becomes this light orange, the lightest color becomes black, and the primary color becomes this reddish orange. My guess is that on the Game Boy, this was achieved by simply flipping back and forth between the object's main palette and the flashing palette. In hindsight, it would have been really cool to set up this project to use Game Boy style palettes rather than RGB values for sprites, but that's not how this project is set up, so we'll have to use shaders. Something I'm learning is that Unity is pretty easy and powerful, but absolutely nothing in it is intuitive. Every time I try learning a new thing, it takes a while for me to wrap my head around its editor. Shaders are pretty simple at a basic level. I was afraid of having to program them by hand, but Unity has this shader graph system that requires no code at all. The original idea was to make a shader that changed the sprite's colors with hard-coded values, then switch to variables after I got that working. It took me so long to get this working. My original idea was to take the exact hex codes of the colors on the base sprites, compare that to the color on the sprite being red, which should be the same, and set that color to the damage flash color. This worked for black pretty consistently, but it didn't really work for anything else. I tried changing it to be values within a certain threshold of the original color, which worked a little better, but seemed to miss out on the green on Link's tunic. After sleeping on it, I finally reached out for help on the Unity Discord of all places, and someone responded to me and told me that there was a replace color node. And that just worked, and I feel really silly about it. Now, I did have to set a color threshold because it wouldn't work with the exact RGB values. My guess is that something about the colors got messed up in some kind of pre-processing, which made the colors ever so slightly off from what was expected. Anyway, now that I got it working with hard-coded values, I just needed to find the colors of the sprite at runtime and pass those to the shader instead. To make it so that Link isn't in his damaged color state all the time, you have to do something called lerping. I don't know what that means, but it pretty much chooses one of two outputs depending on some value I set in code. Learning this actually makes me concerned about future shaders. I don't think it'll be applicable to this game because effects like this are few and far between, but for a larger game, I have some questions. So, in order to actually use a shader, you have to make a material out of it and attach that material to a sprite. A sprite can only have one material, so if you have a lot of shader effects, you just have to put a bunch of lerps back to back like a nested if statement. Also, I probably don't want to use the same material for the enemies as I do for Link, so do I just have to copy paste the shader code for the damage flash to every individual enemy that needs to get damaged? I'm not that far in the project yet, so I genuinely don't know. Now I have basic movement and basic combat down. I've also dipped my toes into shaders, so the next thing I wanted to work on was the inventory and items. Going into this project, I at least had a rough idea of how I would handle most things I've worked on so far, but the inventory is interesting, and I didn't know how to handle it because it exists outside of the context of whatever the current scene is. An inventory isn't like the other objects I've worked on, which only exist in the context of the current scene at runtime. So I did what I'm best at and Googled how inventory systems work in Unity. Here I was introduced to the concept of a scriptable object. Now, everything I've shown you so far is what Unity refers to as a monobehavior. I don't know why it's called that, but it pretty much is used for the objects that you can see or interact with in a scene. Monobehavior scripts are attached to objects and can do things like read and write to various components of the object they're attached to. A scriptable object, on the other hand, exists outside of the scene. You don't need an instance of it to read or write to it. An inventory needs to hold information about your items outside of the context of any one scene. It needs to know things like whether you have an item unlocked or how much ammo of that item you have. It needs to remember this regardless of whether you're in the overworld, in a dungeon, or underwater. That's why scriptable objects work well in this case. I pretty much copied what was on the tutorial I saw online to get started. So going over it quickly, we have the item data scriptable object, which holds the name of the item, an icon, whether it's been unlocked, is stackable, and the max ammo. I also created a script called item instance, which isn't a scriptable object, but it's just a class that holds the item data and the current ammo. Finally, I have the inventory scriptable object. This holds a list of items and methods to add and remove items, as well as getters and setters for the ammo. To test out all this worked, I created a scriptable object from my item data class and called it bomb bag. I then created an inventory object and added my bomb back to it. Of course, it doesn't have any functionality, so let's create that real quick. The first thing I did was add a pickup to the world so I know my inventory methods work. It really is dead simple. It's just a sprite, a box collider, and a simple pickup script that lets me dictate which item to add ammo to and how much. Once I confirmed that was working, I created a prefab for the bomb that is used by the player. All it pretty much has is a few animations for its default state, flashing, and an explosion. After that, I added a script to do things like checking whether you have enough ammo in your inventory and how much damage the bomb should do. We've covered pretty much all of this before, so I won't go into any more detail. The one novel thing I had to do was recreate the actual explosion sprite because I could not find it on the spriter's resource. I had access to the cloud of smoke before and after the explosion, but not the fiery part itself. That was pretty much a good excuse to download a sprite and get familiar with it. So, we are over 5,000 words into the script, and that's pretty much it. At this point, I have about one third of one map done, a basic character and enemy behavior, and some inventory and item management stuff. This doesn't sound like a lot, and it really isn't, but you've got to remember I'm starting from pretty much scratch here. The cool thing about games like this is that once you have the basic mechanics down, creating the rest of the game speeds up immensely. For example, there are a lot of different enemy types, but now that I know how this project handles enemies, I can create new ones without going through the same thought process I needed to create the first one. The last thing I did before stopping and making this devlog is refactor my player controller script. Now, this had gotten out of control as one giant script that handled everything the player did, from movement to animation to combat to item management. And I don't remember a lot of design principles from school, but single responsibility is something that I think applies to much more than just code. I thought it'd be a good idea to have single responsibility here. Speaking of code, you can probably tell by now that my general philosophy in this project is to make it work now and make it good later. I'm not saying this is the best approach, but I found in previous attempts at game dev that I got so bogged down with trying to write good code that I never got anything done. And that leads us to the discussion of the elephant in the room. Did I use AI for this? Well, I'm going to admit straight up that I did use some LLMs to help me work on the project so far. If that's enough to make you disregard this project entirely, I understand. Uh, Let it be known I have the same issues with AI that you probably do. I recognize the horrible economic and environmental impact on pretty much all facets of life, the jobs it has taken, and instability it has caused. However, I find that, like in most things, there is a more nuanced take than just AI bad. It is my opinion that for learning quickly about very specific things, especially regarding computer science, it can be a useful tool for fast tracking understanding. It's generally quicker and less judgmental than going to something like Stack Overflow and can help accelerate understanding. For the sake of transparency and nuance, I thought I would detail the exact extent of how I am and am not leveraging AI in this project. This project will have no AI written code except for testing purposes. By that, I mean if I want to quickly try out something like knockback, I may use some example code to make sure the interaction works, and I have a sense of what functions and methods I may need to use before going in and tuning the programming myself. Even in those cases, I'm not copy pasting any code, so I make sure to review every single keystroke. I even try to minimize how often I do this because the output is usually really bad. I don't have this written in the script, but in the knockback example, it pretty much works so that when you get hit, it adds a constant velocity to your character until you run into a wall and come to a complete stop. And it's actually kind of fun to play with because the knockback is additive. So if you keep running into the same enemy, you can actually shoot out of the map, which is fun to play with, but it's bad code. Similarly, I'm not using any AI agents to directly write code for me. Think of my LLM use as if I'm speaking to a senior developer as a junior dev. Now, this particular senior developer might be pretty incompetent generally, but he does know the tools pretty well and can at the very least point me in the right direction when I'm missing some critical knowledge. Obviously, no art assets will ever be AI generated in this or other future projects of mine. Any finalized art will either be done by myself or I will find a way to hire a capable human artist. Overall, I am trying to minimize any AI use, but I am not barring its use entirely. When I have a new problem, I usually try to start with internet searches, but those have gotten so much worse too, so in my mind, there's really no winning when it comes to trying to learn something like Unity, at least on 2026. I understand if you turn your nose up at this project because of this, but I hope you can at least understand where I'm coming from. And that's all she wrote. If you made it this far, seriously, thanks for watching. This is going to sound like engagement bait, but genuinely, please let me know if this was enjoyable. I mean, did I go into too much detail? Not enough. I feel like I went into way too much detail with the code there, but I've never really done anything like this, and I would like to improve however I can. Writing and editing are two additional skills that I'm hoping to hone with this project. I didn't want to make this first devlog until I had a decent amount of work to show, but now that I'm seeing the word count of the script and coming off of this recording session with a sore throat, I realize I may have wanted to make this first one a lot sooner. I don't know though. I personally like longer form content, but would you prefer more frequent, less featured, shorter videos, or bigger videos showing a lot of progress like this one? Anyway, thanks again for watching. Subscribe and do all the YouTube things if you want to make sure to see the next one.